Join us here at All Pro Web Designs. We're happy to present you with the Learn Basics of Angular and TypeScript. Please hit the like button and subscribe so we can send you all of our new videos as we put them out. Thanks. Enjoy.
Page applications are a big thing these days. They're a departure from the way the web worked years ago. Here's the traditional way that the web worked. When you went to a browser in the old days, like, I don't know, 5 years ago, what you do is you would type in a URL or you would click a hyperlink or something like that, and a request would get sent to the server, and the server would grab an HTML file off a page, or maybe it would run some code and it would generate an HTML page, and it would send that HTML along with any CSS or images or things like that. It would send that back down to the client, to the web browser, and the web browser would grab the HTML and it would display it. It would render it. It would reload the entire page. And that works okay. There's nothing inherently wrong with that, but sometimes you don't really need to reload the whole page. It's kind of a jarring experience to repaint the entire browser and maybe even move the user away if they're working down, they've hit page down a couple times to bump them to the top of the page. Sometimes all you want to do is just update a little bit of text on the page and maybe store something in a shopping cart or something like that. Something that doesn't really require downloading an entire HTML page, which is a lot to drag across the internet, and then rendering it, which is kind of jarring to the user. And this worked really well back in the days when the internet was a way of linking together documents and pictures of cats, which is what the original intent of the internet was. Nowadays, single-page applications have become really popular. And with a single-page application, the model is that, yes, we do initially download an entire HTML page and some JavaScript and pictures and show it to the user, but after that, if they'll click a button or a link or something like that, a request gets sent to the server, and instead of the server sending down an entire page, it just sends down some data. It'll do some processing on the back end, maybe validate something or store something in a database, maybe do a calculation, but all that gets sent down to the client is enough data for the client to update the user interface, and some JavaScript in the client will display that data to the user, maybe update a div or something like that. And we do this through JavaScript. And JavaScript is a decent language for doing this, but JavaScript is not a great language. It's a very small language. It was written in, I think, about a couple of days. And it's not an extremely powerful language. So when we started to build complex things, like if you use an online email client, you think about how complex Gmail is, gmail.com is, or the Azure portal is. There's a lot going on there. It's really difficult as a developer to manage that complexity inside of a language like JavaScript. So what people did to make up for the deficiencies of JavaScript, or the limitations of JavaScript, is that they built frameworks to make that easier, to manage that complexity. And then it's up to you to learn those frameworks, and if the learning curve of the framework would be offset by this idea that we can manage the complexity of a single-page application, managing all kinds of state and doing data binding, things like that. Lots of them come up. They've become so popular that every month new frameworks are being released to manage single-page applications. And one of those was Angular. Angular is a really popular framework. It is open source. You can look at the source code, you can contribute to the source code, you can open bugs and fix bugs. And it takes care of things like data binding and splitting up a complex application into smaller components. And it is managed by a company called Google, which is significant in that Google is a big company, and they've put their name behind it, and they put some of their resources behind it. And so one of the reasons people gravitated toward Angular is because they knew that Google was going to be around for a while. So having a big company behind this means that if it's Joe's framework, Joe might get tired of maintaining it, and then where are we? Who's going to finish this application? Well, Google's probably going to be around for a few years. But they're not just Google. I mean, anybody in this room is allowed to contribute to this application. Angular has a dependency on another open source framework called TypeScript. And TypeScript is an open source framework. Sorry, the paparazzi's here. Okay, I'm back. It's an open source framework. that is managed by Microsoft, which is kind of funny that Google's Angular and Microsoft's TypeScript are working together, because they're competitors. I work for Microsoft, and we have competition, but we also have cooperation. We have co-opetition, So even though we're battling in some areas, we're working together in other areas like this, which is good for you, the developers. It's actually a better experience for that. It's kind of like, I don't know if you followed the United States presidential election, where there were the two candidates clashed, but afterwards they just totally hugged it out, and now they're close friends. Not really, but in this case, it's so TypeScript is a superset of JavaScript. It means that you can type JavaScript and it'll compile, it'll be valid TypeScript, but add some other things to it as well. And when you add those other things to it, I'm going to talk about in a second what those other things are, but it makes it easier to do JavaScript development. It handles some of the limitations of JavaScript, and then when you're done, it transpiles down to JavaScript. And let me tell you what that means really. So I'll start with TypeScript. So the idea behind transpiling, if you're a software developer, you probably know about compiling. The word compile, it means to take a text-based language like C# and turn it into binary languages, ones and zeros. That's what compiling is. Transpiling is like that, except that we'll take one text-based language, in this case TypeScript, and we'll turn it into another text-based language, JavaScript. And that's significant because browsers don't understand TypeScript. They have no idea what TypeScript is. They can only run JavaScript. So this step is important. TypeScript's easier to write, it's easier to read, it's easier to maintain, but it doesn't do you any good with the browser. You have to turn it into something the browser understands. And that's what JavaScript does. That was what transpilation does. So TypeScript files by default will have a TS extension, and JavaScript files that are generated from it by default will have a JS extension. And there's one other file actually generated by default when you transpile, and that's called a map file. It has a .map extension. And the reason this is important is that there are tools inside of every major browser. Usually you hit F12 to do it, and they let you step through the code and debug the code. They're really popular. They started with Firefox's Firebug, but now they're built into just about every browser. And what the map file does is it allows you to step through the JavaScript code, but it'll actually display the line of TypeScript code that generated that JavaScript code. So then you can actually read the code that you wrote and as it's executing, which is really a nice experience. And just to give you a picture of that, here's some TypeScript. It looks kind of nice, and when it transpiles, it turns into JavaScript. The JavaScript's a little bit ugly, you'll notice, and the reason is because we're going through some hoops to try and make this do things that originally JavaScript wasn't really designed to do. And what I'm going to do is I'm going to show about 30 minutes of slides and about 30 minutes of samples, so we'll see some examples of that later on. To do this transpilation, there's a command line, TSC. So you will install TypeScript, and it's a really quick, it's like a 1-minute install. And then TSC will, by default, it'll just transpile all the TS files in the current directory. But you can add some switches. You can say -P to point it to a specific file or a specific folder. You can say -W, TSC-W, which is nice because what that'll do is actually TSC will stay in memory and it will transpile changes, any TypeScript file as it changes. So every time you make a change to a TS file, it'll automatically generate a JS file, which is really nice. You can do it that way. There are configuration files you can create, so you don't have to type that every time. If you want to have certain settings always happen with TypeScript, you could do that. You can set up one of your automated deployment processes. Grunt, Gulp, and Webpack are really popular ones in the JavaScript world to automatically run TSC as part of the deployment with certain options set. You can set up Visual Studio or Visual Studio Team Systems to do your automated deployment. It's all part of your deployment process right here. And TypeScript has some advantages. It does let you split things up into smaller components, but really the biggest advantage, there's two really big advantages. One is that there's a board that's creating what's called the EcmaScript standard. So the JavaScript language is really the EcmaScript language. That's the official name of it. JavaScript is the implementation of the EcmaScript language specification. And some of those specifications have been proposed, but they haven't been implemented in browsers yet. So if you want to start using some of those features that are in the next version of JavaScript, TypeScript lets you do that, and then it'll transpile it into some JavaScript that will make that happen. TypeScript supports strong data typing. And strong data typing means that when I declare a variable, I specify at the time I declare it what kind of data I'm allowed to store in that variable. And this is something that JavaScript really hasn't had. JavaScript has always been this thing where you could declare a variable, you could assign a string to it, and later on assign a number to it, and later on assign an object to it. JavaScript doesn't care. On the one hand, it makes it a very flexible language, but on the other hand, it's easy to let subtle bugs creep into your code that are hard to track down because of this. And here's a simple example of that. If I have these lines of JavaScript here where I've got two variables, num1 and num2, you can tell by the names they're probably supposed to be numbers, and I assign 5 and 10 to them respectively, and then say hundreds of lines later, or maybe inside of another function or another file, I change the value of num2, and I change not only its value, but I change its data type. So now it's not only storing a number, it's actually storing a string now. JavaScript is fine with that. And imagine that hundreds of lines later, I want to output the value of that. Maybe I want to assign the num1 plus num2 to the variable sum. And who knows what the value of sum will be in this example. It'll be 510, right, 510. It'll be a string, it won't even be a number. And that might not be what we expect. So bugs like this, they're hard to track down. If you didn't realize that you had accidentally stored a string in here, that could be a problem. It's hard to check down. With Java or with TypeScript, what you can do is you can declare. When you declare a variable, you can declare it as a particular data type. So I can say num2 is a number. Only numbers are allowed to be assigned to it. And then later on, if I try to assign something that isn't a number to it, I'll get an error. In my ID, I'll get a little red squiggly line, the translation will not happen. I'll get some message that'll come out that either in the console or in the log that'll tell me early on, this is a problem. And as you know from software development, the earlier you can see that there's a problem, the easier it is to fix that problem. Okay, here's the config file that I mentioned earlier. If you can use command line switches, or you can put things into this tsconfig.json. These are basically typing the same thing, same command line switches over and over again. You can do things like specify what version of JavaScript do I want to generate. I can specify whether or not to generate a map file. I can specify whether to remove comments from my TypeScript. Maybe I want to keep comments in for myself, but I don't want those comments to be in the JavaScript because maybe they contain some secrets that I don't want the end user to see. I can specify whether I want to allow a data type of any. Any is essentially it's like a variable keyword where you can say that this one I'm not really being quite so strict about this particular variable. I can allow or disallow that in my configuration. And I can also exclude things from what I want to transpile, whole folders. This is useful if I want to, for example, bring in an external library. Maybe it doesn't have any TypeScript files in it, or maybe it has TypeScript files and they've already been transpiled. I can ignore that and things will go a lot faster by adding this exclude array.
Thanks for watching our first course on learning the basics of Angular and TypeScript. The next course will start in just a few minutes, and if you could please subscribe and press that like button, it sure helps us out so we can keep making these videos for you. We hope that this is beneficial for you, and in the next application you will be starting your first app of Angular. See you there.